Okay, projectile motion, right? Projectile motion. So at the last class, we discussed about linear motion equations. So in the projectile motion also, we have to use linear motion equations. We have to do the same thing. Not the same, I mean similar, right? In this part as well, we just have to use linear motion equations. So if you have practiced linear motion equations, this part is going to be easy, right? So there are three types of questions that you would get. This is one type. So initial velocity is like this, then it hits the ground. So this is one type. You can take the notes as I'm doing this. This is one type, right? One type of questions you get. Other one is like this. There's U, then there's T. Then they might ask horizontal range, maximum height, flying time, those kind of stuff. Other type is, so it is projected from a height. Let's say simple h, and it is projected like this. So these are the three main types you would get questions from projectile motion, right? You can take this down. You can take this down. So when you're solving problems, this is all you have to do. Like whenever you have to solve a problem in projectile motion, you have to apply equations horizontally. This is the only equation that you need to apply for horizontally, right? Other one is vertically. So vertically you can apply any of the linear motion equations. So the equations are, take notes, right? This one, v squared u squared plus 2as. Other one, s equals ut plus half at squared. So you apply all these equations vertically. Horizontally, you have to apply s equals ut to this side. That's all you have to do. Okay. Right. Take it down. Right. Then let's see how to apply. I'll just take this this projectile motion. So the initial velocity u and this inclined velocity is theta. So let's say this point is O, and at the maximum height point is A. Here the point is B. And you have a gravitational acceleration downwards. Acceleration horizontally is 0. All the acceleration is only downwards, right? That is the only acceleration for projectile motion. Okay. The thing is, so as this object moves in this path, you can see it keeps changing, right? Its direction keeps changing, and it is a bit complicated. So what we are going to do is we consider this motion horizontally and vertically separately. Okay. So if this object moves like this, horizontal component moves from here to here when the object moves here, and then the vertical component goes up and comes down. It goes up. So simultaneously this component, horizontal component, goes from here to here. As it moves from like this, vertical component moves here, then comes back, right? So you have to consider these two motions separately. Separately. Okay. So you can see gravitational acceleration is applicable only for this motion. For this motion, there is no acceleration. This is a constant velocity, right? So, so you have to consider components. This is u cos theta. This is horizontal component of the initial velocity. This is the vertical component of the initial velocity, u cos theta. This one is u sin theta. So for this one, I'll apply separately. Let's say you need to find time that requires for this object to move from O to A. So what you're finding is the time from here to here. So you can apply equations only considering the vertical motion. I'll just apply this equation. So at the top, we know the vertical velocity is 0. Vertical velocity is 0 at the top. And the horizontal component, it doesn't change. It is a constant, right? There's no acceleration to this side, so it doesn't change. But I'm only considering vertical component. So I'm applying equations vertically upwards. So at the top, velocity 0. Initial velocity is u sin theta minus acceleration is downwards. I'm applying the equation upwards, so this becomes minus gt OA. So take gt to this side, u sin theta, then TOA is u sin theta divided by g. So this is what you have to do in order to find the time required. In order to find the time required to reach the maximum height. This is the maximum height. I'll say that capital H. Okay, take this down quickly. And if you took it down, send me a thumbs up, right? Okay. Take it down, those who couldn't take it down, right. So what I found is the time required to reach the maximum height. You don't have to remember these equations. You only have to apply one of the linear motion equations, right? Okay, then we need to find a flying time. Flying time means for the whole motion. So I'm applying equations from O to B. For this one as well, I'm considering only the vertical component. So if you find this time, it is equal to the time required for this motion, whole motion. So for this one, I'm applying this equation. The reason I'm applying this because I can make this S0 as it comes back, right? It goes up, it comes to the initial position. So the total displacement is 0 after the flying time for the vertical component. That's why I use this equation. So vertically upwards, the velocity, initial velocity u sin theta, t plus half minus gt squared. Take this whole term to the other side, u sin theta, then cross multiply 2u sin theta divided by g. You have to divide both sides by t, right? You can get rid of a 1t. So this is TOB. Actually, this is what we call flying time. So when you have to find this one, you have to apply this equation. It is not a rule, but it is easier if you apply that. Take it down. Okay, so we found the flying time and the time required to reach the maximum height. Then I need to find this maximum height. So what can we apply? I'm applying equations from O to A, this point A. This equation is better to apply because vertically upwards, vertical component is 0. So I can make this term 0. So it is easy to apply this equation. Then u squared, vertical component u sin theta, u squared sin minus 2g, maximum height is capital H. Take this to this side, u squared sin squared theta divided by 2g, u squared 2g sin squared theta. Okay, so that is the maximum height. You don't have to remember these, right? Just apply the equations. So this is what we have to do for any questions. That's why I'm giving you this. Okay, take it down. Okay, so we found the maximum height. Then there's something called range. That is the distance from O to B. So to find the range, now I'm applying this equation, ut horizontally. Because there's no half at squared. That is 0, right? Because acceleration is 0 to this side. There's no acceleration horizontally. So S is from here to here. S is R. U cos theta. That's the horizontal component. Horizontal component times time. That is the flying time, right? Flying time we found here. TOB. Just substitute it here. So that is 2u sine theta divided by g. 2 take u to this side, u squared sine theta cos theta divided by g. So that is the range. Okay. So that is the range. Take it down. Send me a thumbs up. One should. If you have any issue, you can ask me in the chat box, right? Right. So now we have this equation range. So about this range, you need to know a couple of things about range. There's something called Rmax. Rmax means maximum range. So in order to have the maximum range, you should know that this angle should be 45 degrees. We can actually derive that, but it is not in the syllabus to derive that. Just remember that to have the maximum range, theta should be 45 degrees. 45 degrees, right? So if you can substitute 45 degrees in this equation here. 2u squared over g sine 45 cos 45. 2u squared over g sine 45 is 1 over root 2. Cos 45 also is 1 over root 2. Root 2, 2, right? Then these two cancels off. Then the maximum range is equal to u squared over g. R max. So to have the maximum range, you need to have that angle to be 45 degrees, right? 45 degrees. So this is R max. Okay, another point you need to know about range is you have these two angles, theta and 90 minus theta, to have the same range. Same range. Okay. Take it down as well. Theta and 90 minus theta. For both theta and 90 minus theta, you will have the same range. Right, take it down. So for an example, it is like if you project an object at 30 degrees. If you project an object at 30 degrees, it would land like this. Let's say this is 30 degrees. For the initial velocity to be 30 and u, let's say it lands here, this point. So what is 90 minus theta? This is theta. 90 minus theta is 90 minus 30. So that is 60 degrees. So 60 degrees as well, for 60 degrees as well, we will have the same range. That's what it means. We will have the same range. Okay. So if you project another object, let's say this is 60 degrees. So this is 60 degrees. Now the object goes higher, but it would land at the same place. So this angle is 90 minus theta, so that is 60 degrees. So that is a very important point, right? So to have the same range, you have two angles all the time. If one angle is 15 degrees, another angle is 75 degrees. That is 90 minus theta angle. Okay. Then the other point is, for 45 degrees, let's say this is 45 degrees, you will have the maximum range. So that maximum range is higher than this range, right? This is a normal range. So for the R max, it is 45 degrees. You can take this down. For R max, it is the maximum distance range that can move for 45 degrees. For 30 and 60 degrees, you have less range. You can take this image. Once you get the image, drew the image, send me a message. Once you take down the notes. Okay, right. So that is mainly like everything about projectile motions, right? So the remaining theory parts will be I'll be explaining with the questions, right? Okay. Get the tute, then try the first question, projectiles first question. You can send the answer in the chat box. Try the first question. You can draw a sketch. Initial velocity is horizontal, right? 20 meters per second. Height 20 meters. So it would have a motion like this. So once you solve the question, you can send the answer in the chat box. So you know that it hits the ground here like this, right? So what they ask is this velocity. It hits the velocity. It doesn't hit vertically, right? It hits with an inclination, right? So this is point O. It starts from O, ends at A. So you have to apply equations horizontally and vertically separately. Horizontally and vertically separately, right? So here the velocity, you can think about two components of this velocity. I'll say this component V1, vertical component. Horizontal component is V2. You can resolve this V into two components, V2 and V1. So that is what we do, right? Always separate into verticals and horizontals, everything. So we know that, what do you know? Horizontal velocity does not change. It is a constant velocity. There's no acceleration to this side. So this is the horizontal component. It doesn't change. So the velocity here also should be 20. Doesn't change. 20 meters per second. Doesn't change, right? There's no acceleration to that side. Other thing is you have to find this V1. That is a vertical, so apply equations downwards, vertically. I think it's better to apply this equation, right? Because they haven't asked about time. U square 2s. So the final velocity V1 squared equals initial velocity component is 0. Whole velocity here is horizontal, right? 20. There's no velocity to this side. Vertical velocity. That is not. This velocity is completely horizontal. There's no component. So the vertical component is 0 here. So 0. plus 2g, g means 10, height is 20. So what do you get? 20, 20, 400. So V1 is 400 root, that is 20 meters per second. So V1 we found 20 meters per second. This V2 also is 20 meters per second. So what they ask is none of these but this V, right? This V. So we know, so you can draw a rectangular or a circle to this, not a circle, I mean a rectangle to this. So we know that there's 20 to this side and 20 to this side. So the resultant of these two velocities should be the diagonal, right? So you can use Pythagoras theorem and find this velocity. So what is it going to be? So V squared is going to be equal to 20 squared plus 20 squared. These are vector. This is about finding resultant, right? So V squared, that is 2 times 20 squared. Take the root from both sides, square root of both sides. So this becomes root 2. 20 squared, when you take the root of that, it becomes 20. So V is just 20 root 2 meters per second. This is the resultant velocity. What they ask is the resultant velocity. When they say just velocity, it means resultant velocity, right? Not vertical or horizontal components. They are not asking about components. They are asking about the resultant velocity. Okay, then they ask the angle that it hits the ground. So this is that angle, theta. So how do we find this angle? If you think about this also is 20. So you have to apply trigonometry to one of these triangles. So when you say tan theta, you can take tan theta, opposite divided by adjacent. Opposite is 20, adjacent also is 20. So this is 1. Tan theta 1 means theta is 45 degrees, right? So it hits the ground at a 45 degree angle, right? Take it down. If you have any problems, send me a message, right? I know some of you may have problems. So those who completed that, try second question. Try second question. So F-35, that is a fighter jet, right? You know that. You have to convert these into meters per second because the gravitational acceleration in meters per square second. You have to convert everything into meters per second. Last week I told you how to do that easily. Multiply this by 5/18, so it converts into meters per second. 118, 54 means 3 18s. So 30 meters per second. Two kilometers is 2000 meters, right? So the F-35 flies at a 2000 meters above the ground. Then it drops a bomb. The bomb doesn't fall like this, right? Due to the speed of the F-35, the bomb gains the initial horizontal velocity. So its motion will be like this. Once it is released from here, its motion will be like this. So what they ask is this R. They are asking about a distance, right? R. So the initial velocity is completely horizontal, right? Vertical component is 0. Vertically downwards 0. So which one should we apply? In order to find this, you need to get the flying time. So to get the flying time, which equation can we apply? This one. You have to choose the easiest equation to be applied, right? So downwards S is 2000, that is a plus. Because this is, I'm applying equation downwards, so it is 2000. Initial velocity 0. Half acceleration downwards 10. T squared. Then 5, half cancels of 5. 5t squared equals 2000. Divide both sides by 5. 4, so 400. T squared is equal to 400. 400 means 20 squared. When you take the root, it becomes 20 seconds. So to reach the ground, it takes 20 seconds. So that's the flying time of the bomb. Flying time of the bomb, that is 20 seconds. Both are same, right? This time and this time, they are the same. They happen simultaneously. Then you can apply S equals ut horizontally to find R. So initial velocity, we know horizontal component does not change. That is 30 meters per second. Times time. Time is 20. 3 times 2, 600 meters. Got it? So if you have a target, and when you are flying on F-35 horizontally at this speed, you have to see the target from the ground at a 600 meters, right? You cannot drop the bomb right above the target. Okay. You have to drop the bomb at a 600 meter ahead. The target should be ahead 600 meters from the ground. Right? Okay, take it down. I think everyone got that, right? If you have any questions, please send. The answer, is it not given? 600 meters. What's the problem there? Sorry. Yeah. The velocity should be 150, right? Yeah. Sorry. Yeah, 150 meters per second. So you have to apply 150 here. So 150 times 2 is 300. So it becomes 3000 meters. Yeah. 3000 meters. 150 times 20. So it is 3 kilometers, right? Yeah. The conversion was, that simplification was somewhat, yeah. That should be 3 kilometers. Right, then try the third question. Third question. That's a similar question to the first one. Try the third one. So for this one as well, you have to find vertical and horizontal velocity components separately. Then get the resultant of those two. Yeah, the last time I told you how to convert this into a meters per second at once. So to do that conversion, you just have to multiply by 5 over 18. You need to remember that, right? 5 over 18. So you can convert this into meters per second at once. You need to remember this factor, 5 over 18. Okay. Okay, so those who got the answer for third question, send me. Initial velocity, vertical component 0. So we know horizontal component does not change. So we know V2 is 15. V1 is, you can apply this equation to find V1 vertically downwards. So V1 is squared. U is 0. Plus 2 times acceleration downwards 10 times S is 20. So this is 400. And this is the same question. So this is 400. 400 root is 20, right? 20 squared is 400. So V1 is 20. V2 is 15. It doesn't change. Then draw a rectangle. In order to find the resultant. They are asking about the resultant. Draw the way. To this side 15. This side, and to this side 20. You draw a rectangle, then the diagonal is the resultant. This is the diagonal which is going to be the resultant. So this is 15, this also is 15. Just apply Pythagoras theorem to this triangle. V squared equals 15 squared plus 20 squared. 15 squared is 225. 20 squared is 400. 625 if we add these two. 625 means 25 squared, right? So when you take the square root, it becomes 25 meters per second. So it hits the ground at 25 meters per second. Answer is first one, yeah, correct. Then try fourth question and send me the answer. Let's see who gets the correct answer. Fourth question, right? Try that, fourth question. So let's see who gets the correct answer for the fourth. Okay, someone send me the answer for the fourth one. It doesn't matter, you got the... Doesn't matter if you get the wrong answer, send me the answer, please. Right, so let's discuss this. So we have given three objects, and those objects are at the same height. One object is dropped. So the vertically initial component is 0, right? For A. For B and C also, initial velocity component, vertical component is 0. All A, B and C, vertically downwards component is 0. Initial velocity is 0 for all A, B and C. All the velocities are horizontal for B and C. So the vertical component is 0. And the height, they are the same height. So if you apply this equation vertically downwards for A, B and C, what do you get? You get H. This becomes 0. Initial component is 0 for all. Gt squared 2h divided by g, root of that is time. So you should know for all three the time required to hit the ground is same. Hit the ground is same. Got it? Everything is same, right? I mean vertical motion is same. Vertical motion is same, but the horizontal that changes, right? But what dictates the time, flying time, is the vertical motion, right? This goes to this side because initial horizontal velocity is higher, but the allowed time for that to move is same for all three, right? So vertical motion is identical for all three, but paths change because horizontal velocity is different. So the answer should be third one. Yeah, third one. Right, then try 10th question. What's the answer for 10, right? 10th question. What's the answer? You know, right? We discussed that. You don't have to find that, you just have to remember that. Yeah, the third one, right? Then try 11th question. So this is this type of a motion. This type, right? So what they ask is this theta. Theta is what they ask.
Recording is
Okay. First, I will find the flying time. Let's say that time is t for the whole motion. So to find the flying time, this is the equation we used. I'm applying equation from O to B vertically. So the vertical component goes up, comes down as it goes on the projectile. So the displacement is 0, right? Vertical component u sine theta, horizontal component u cos theta. So we need the vertical component u sine theta. Time plus half minus g, acceleration downwards, right? So it is minus here, t squared. Then divide the whole equation by t and put this term at the other side. Half gt equals u sine theta. Cross multiply 2u sine theta divided by g. So that's the flying time. We derived this earlier as well, right? Then we need to get an expression for range. So to involve range, we have to apply equations vertically. Sorry, horizontally. This equation. So horizontal range, that is root 3 u squared over 2g. They say like that. Horizontal component is u cos theta. Time is 2u sine theta divided by g. Okay. Right, let's see. Then u cancels off, the u squared cancels off from the both sides, g cancels off. So what you get is 2 sine theta cos theta equals root 3 divided by 2. Right? Root 3 divided by 2. There's this equation for this. 2 sine theta cos theta is equal to sine 2 theta. There's this equation. 2 sine theta cos theta equals sine 2 theta. You need to remember this. Sine 2 theta is 2 sine theta cos theta. Instead of 2 sine theta cos theta, you can apply sine 2 theta. So sine 2 theta is root 3 over 2. So what is root 3 over 2? Root 3 over 2 is sine 60. Sine 60 is equal to root 3 over 2. So instead of this one, you can put sine 60. So sine 60 equal to sine 2 theta. Then 60 degrees is equal to 2 theta. Divide the equation by 2. Theta is 30 degrees. Theta is 30 degrees. Yeah, the answer should be not the first one. Answer should be fourth one. Why? We only got one of the answers, right? 30 degrees. But do you remember, to have the same range, we have two angles always. What are the two angles? Theta and 90 minus theta. So this is like theta. Another angle should be 90 minus theta. 90 minus theta is 30. One angle is 30, another angle should be 60. So for both 30 and 60, you would have this range. Okay, take it down. Then once you take it down, thumbs up, right? If you have any issue, please send. If okay, thumbs up. Right. Try 12th question. 12. Separate this into components. 100 root 2 sine 45 cos 45. So cos 45 sine 45 both are 1 over root 2, right? So this is 100, this also is 100. Because 100 root 2 times cos 45 is 1 over root 2. Sine 45 also is 1 over root 2. So for both you will get 100. Goes like this. So what they ask is maximum height. Not the range, right? Height. Capital H. So what's the answer? So which equation should we apply? You only have to apply one equation. This one. You don't need time. So you just apply this one. Vertically. So vertical component 0. Final velocity from here to here at initial velocity 100 squared minus 2 10 capital H. So 20H is equal 100 squared. I'll just write 100 2 times. Then divide by 20. So we have 5 20s. 5 times 100 is 500. So the maximum height is 500 meters. Answer is second one. That is the easy question, right? So if everything okay, send me thumbs up. Then try 13. 13 try. 13. 13 is part of this question, the same question. Try 13. So within the third second, at the last class I discussed that not after third second, right? Not after. What they ask is within the third second. So that is a 1 second, right? Vertical height. So let's say, so what is third second? Third second is t equals 2 to t equals 3 times. This height, t equals 2, t equals 3. Within that. So if we have fourth second, it is t equals 3, t equals 4. Within this range. If you have 60th second, 59, 60. So how do we find that? T equals 2, t equals 3. So this is S1. Take one of to be S1. From here to here S1, from here to here S2. So you have to find S1 minus S2. That is the time distance traveled within the third second. So first find for S1. Apply equation from here to here. This equation. Vertical velocity is 100 here. Times 3, right? Minus half 10, 3 squared. So you get 300 minus 5 times 9, 45, I think. 5 times 9, 45. 300 minus 45, 255. So that is S1. Then apply the same equation to find S2. Initial velocity 100, but the time now is 2. From here to here, time is 2. Minus half 10, 2 squared. 200 minus 5 times 4 is 20. So 118 meters. This is S2. You need S1 minus S2. That is 225 minus 180. 5, 4. Yeah, it is 45 meters. So that is the distance, vertical distance, right? I mean vertical displacement traveled within the 3rd second. So when you get questions, you should know that. Okay, take it down, and if it is okay, thumbs up. Then try 21st MCQ. 21st MCQ. First, draw a sketch. You have to try by yourself as much as possible, right? That is the important stuff. Yeah, 225 minus 180 is, what's the value? 5. 12 minus 8, 45. Yeah, it is 45. What's the problem? The answer. Okay, we'll check that, right? I think there's an issue with the question. Please send a message. What's the issue there? If someone noticed that. First, we'll try 21st question, right? Because we are running out of time. Try 21st question. If someone notices if there's an issue with the question, please send a message. This is an easy question. So the building height is 20 meters. So what they ask is time required to for that to reach the ground. Yeah, I think the answer should be 5. So what you have to do is just apply vertically. Then you can find the time. This equation. So u is 0, right? Vertical initial velocity is 0, but it gradually gains the velocity. Height 20, half 10 t squared. 2 cancels off, 5 t squared equals 20. Divide both sides by 5. So you get 4 here. 4 equals t squared. Then t is equal to 2 seconds. Yeah, the answer is 5th one. That is an easy question. Then try 17 and send me the answer. Try 17th. And send me the answer. 17, right? Send me the answer. Third one. Yeah, answer is third one, right? Why? Acceleration, I told you, acceleration is only g downwards. To horizontal direction, acceleration is 0 all the time, right? The reason for that is I have told you, I think, at the last class I told you, think about acceleration in terms of what? Force, not velocity, right? Acceleration is rate of change of velocity, but don't think acceleration in terms of velocity, because it is somewhat confusing to think about that. It is easy to think about forces applied on an object, right? So we know what's the force applied on an object at projectile motion. Only force is mg, right? mg is the only force applied for an object having a projectile motion, mg downwards. So the force is downwards, that is the only force. So the acceleration also should be downwards and constant. Force is constant downwards, so the acceleration also is downwards. We don't have a force to horizontal direction. We don't have force horizontal direction, so we don't have acceleration. The reason is F equals ma, right? We have to think about this acceleration in terms of force. So anything that happens to the force happens to the acceleration. Got it? Always think about acceleration in terms of force, unbalanced force. So we don't have a horizontal acceleration because we don't have a horizontal force. Then try a 16th. Send me the answer. 16th. Yeah, for 16, answer is fourth one. Answer is fourth one because throughout the whole motion, acceleration is 10 meters per square second downwards. It doesn't change, it is a constant. So equal at t and equal at t. They are the same, right? 10 at t is 10, at p also it is 10. So that is only just vertical. It is obviously vertical, right? So it is vertical component. Okay. Then try a 19th question. Draw a sketch to that 19th question and send me answer. Draw a sketch first. So this problem is slightly different. From a height 300 meters, 30 degrees. So this is what happens. What they ask is capital R. So in order to find capital R, you have to apply S equals ut horizontally, but before that you need to find time. 70 meters per second to this side, 70 cos 30. Horizontal initial component. I'll separately find that. 70 cos 30 is root 3 over 2. 35 root 3. That's the horizontal component. Vertical component is 70 sine 30. So sine 30 is half, right? Everyone knows that. So the vertical component is 35 meters per second. So in order to find capital R, first you have to find the flying time. Flying time is for this whole motion. You can find that at once. So how do you find that at once? Just apply this equation for the whole motion upwards. Okay, so what happens as the object goes on this projectile? Think about the behavior of the vertical component. As it goes up, this component goes here. As it falls down, this vertical component reaches here. So what's the final displacement? You are applying the equation upwards. Actually, it is behind now, right? Behind the origin, starting point. So you have to substitute displacement as minus 300. Minus 300. Right? Then vertical component initial velocity 35. Time is t plus half. Acceleration 10. Actually it is minus, right? Because acceleration is downwards, you are applying the equation upwards. Minus 10 t squared, right? Minus 300 equals 35 t to 5 minus 5 t squared. You can take this to other side. Take this to this side. Equals 0. So we formed an quadratic equation to find the time. Quadratic equation. So we have to see, divide the equation by 5. Minus 6t. T squared. So you have 1 times 60. You have to factor it, right? 60 means 5 times 12. So this minus 7, you can write it as minus 12t plus 5t. Minus 60. Got it? This minus 7t, you can write it as minus 12 plus 5. You found that using this one, right? 5 times 12. Okay, now factor it. Take t out, t minus 12, plus take 5 out from this, t minus 12 equals 0. Take t minus 12 out. You get t plus 5 equals 0. So t minus 12 equals 0 or t plus 5 equals 0. T cannot be negative. So you can reject this answer. So the answer should be this one. Time should be 12 seconds. So that's the flying time for this. Okay, 12 seconds. So once you know the flying time, you can find the horizontal range. If you know the time for the whole motion, you just have to apply equation from here to here. S equals ut. Range equals horizontal velocity component 35 root 3. Time is 12. 12 times 35. So how much is it? 12 times 35? 7, 5, 3. 420. Please simplify that if I didn't got the answer. So the answer should be 420 root 3. And if you have any issues, send me the answer, and once you take this down, thumbs up, right? Do we have the answer? Yeah. 420 root 3. If you have any issues with this, so okay, thumbs up, right? Okay, I think I think no one has any issues, right? Then we'll try some of the essay question. Try second essay question. After 21 there are essay questions, right? Try second essay question. It is a similar question, right? Try that. Press draw sketch. So resolve into components. 8 sine 30 is 4. 8 cos 30 is 4 root 3. That's the first step. Then apply the equation from here to here. Find the time, flying time. Then apply S equals ut horizontally. Find R. That's what. If someone got the answer, you can send a message. This is minus 12. 40 plus half 10 minus t squared. 40 minus 5t squared minus 12. So minus 5t squared, take it to the other side, becomes plus 5t squared. 40 becomes minus 40. Minus 12 is at this side, right? So whole thing is equal to 0. So to factor it, we need 5 times 12. 12 you can write it as 4 times 3. you have to make 4 here. Instead of 12, I can write 4 times 3. Can we make a 4 here? Again, I can write this 4 as 2. 2 times 2. So what are the factors? If someone got the factors, please say me. Okay, we have 6 times 10. Yeah, this is 6 and 10. So minus 4 can be written as minus 10t plus 60. Minus 12 equals 0. So minus 4 is written as minus 4 plus 6. Then take 5t out. This is t minus 2 plus 6 out, t minus 2 equals 0. Take t minus 2 out. 5t plus 6 equals 0. So t should be equal to 2. Because time cannot be negative. T should be 2 seconds. Then apply S equals ut horizontally. If someone got the answer, send me, right? So horizontal component 4 root 3. Time is 2 seconds. So we have 8 root 3 meters. So the thing is, you cannot leave the answer like this for an essay question, right? You have to give the answer as a decimal answer. It should be a decimal answer, right? So root 3, we know that root 3 is 1.73. You have to do this substitution. Otherwise, sometimes they don't give marks, right? If you leave the answer like this, you have to get it as a decimal. So 173 times 8. 24, 56, 58, 13. So the answer is 13.84 meters. So if you need to get the marks for the final answer, you need to give this in this form. Okay. For essay questions, for MCQs you don't have to, but for essay questions you have to simplify up to here, right? Otherwise they won't, sometimes they won't give you the marks, right? So okay, thumbs up, right? Okay, I think there are some of the few questions remaining. Please do those questions as quickly as possible, right? At home, right? So there is going to be a class on this Saturday as well, Saturday 8 p.m. So we will be discussing Newton laws, that is F equals ma, how to apply Newton's laws. So the only new equation is going to be F equals ma. So to practice that class will be very useful to practice F equals ma stuff, right? Okay, so that will be on the Saturday 8 p.m. that class. So the remaining questions before that class, you have to do these remaining questions. And if you have any issues with the questions, you can send me a message and I'll resolve that question. Okay, so we'll see you on Saturday, and good night everyone.